All right, I'm going to be working the solutions here to 1.4 solving equations. And we're going to go ahead and start here with the first problem. We are asked to find the real solutions for this radical equation. So what we want to do is recognize, first of all, that this is a radical equation. And we can tell that because we have this cube root. So the method to do this is first to isolate the root by itself. So to do that, I will subtract 2. Oh, I got to reset this. Hold on. Come back in here. Okay, there we go. Subtract 2 from both sides. That'll leave us with the cube root of 4x minus 4 equals -4, because -2 minus 2 is -4. Now, the important step, we've isolated the radical. We will raise both sides to the third power to kill off the cube root. And we have to do that on both sides. So when we do it on the left side, kills off the cube root, we're just left with the 4x minus 4. And then over here, we're going to do -4 times -4 times -4, which is -64. And then we will just solve this little linear equation. We'll add 4 to both sides. So we get 4x equals -60. And then at that point, we can divide both sides by 4 to isolate the x by itself. So if we do divide by 4, we'll get x is -15. All right, let's check that answer real quick. We have a solution that is -15. Check the answer. Good. One thing I didn't mention is on that problem, because I cubed both sides, and that's an odd number, I don't necessarily need to check my answers in terms of if I get an answer, it should work. If this was an even number, then of course we would have to check because we could have possibly extraneous solutions. Okay, next problem, number 2. So for this one, another radical equation. And the root is already isolated, right? It's by itself on both sides. So that means I can go ahead and go to the next step, which would be to square both sides. And now I need to remember that I'm going to have to check my answers because I'm raising both sides to an even power. Left side, the squared and square root cancel. You get 4 minus 3x. On the right side, you get x times x, which is x squared. And now we have a quadratic equation. So what I'm going to do is just move all my terms to one side. So I'm adding 3x to both sides, and I'm subtracting 4. And now that can be factored. And you know what? I'm just going to point out, because this happens quite a bit, you can always change the order. You can move the 0 to the other side. So I'm going to do that because that looks more like what we see more often is the expression on the left and 0 on the right. Now this quadratic can actually factor. It's going to be x plus 4, x minus 1 equals 0. And then we set each of those factors equal to 0, which I'm not going to show. I'm just going to trust that you can get those two answers, -4 and 1. And now we have to check them. So when I say check, I mean go back to the original equation. And let's check. So if we check x equals -4, let's see what happens. You get square root 4 minus 3 times -4, and then equals -4. And this is square root of, let's see, that becomes 4 plus 12. So 4 plus 12 is 16. So this is not true. The square root of 16 is 4, and that is not equal to -4. So that doesn't work. Let's check our other solution. It could be that this one doesn't work either, but let's see. So square root of 4 minus 3 times 1 equals 1. So that's square root of 4 minus 3 is 1. Square root of 1 is 1. That is true. So we only have one solution here. X equals 1. Let's check it. One solution, 1. All right, another radical equation. All right, so isolate the radicals. So I'm going to move the 3 to the other side. So when I move the 3, that means I'm going to subtract 3 on both sides, which gives me that. Now I'm going to go ahead and square both sides because I've isolated the radical. On the left side, I get 3x plus 1. On the right side, you actually have to FOIL that. So you have to do this times itself. Okay, so do your FOIL and all that, and you should get x squared minus 6x plus 9. And again, we have a quadratic equation. So I'm going to move everything to one side. 0 equals x squared. I'm subtracting 3x on both sides. So that gives me 9 minus 9x. I'm subtracting 1. So that should give me plus 8. And then again, I'll write it the other way just to make it a little easier for us. And that should factor. Okay. That should factor to be x minus 8 times x minus 1. And then we have 2 solutions, 8 and 1. Now we check them. So I'm gonna go a little faster here. Let's check 8. So if I check 8, 3 times 8 plus 1, does that equal 8? So replaced all the x's with 8s, we get 3 plus the square root of, let's see, 3 times 8 is 24, plus 1 is 25, equals 8. And the square root of 25 is 5. So 3 plus 5 is 8. That is true. Okay, so we know that that's an answer. Now let's try 1. 3 plus the square root of 3 times 1 plus 1 equals 1. 3 plus, that's 3 plus 1, that's 4, square root of 4 equals 1. And that's 3 plus 2 equals 1. And that's not true. So that is not a solution. So we only have one answer, and it's 8. Check it. All right. Next problem. Okay, now we're getting complicated here. We got 2 radicals. So this was a special type of problem. If you have 2 radicals, then what you want to do is isolate one of them. So I'm going to go ahead and isolate this one. So I'm going to move the other radical to the other side. And when I do that, it becomes a positive. So it becomes 6 plus the square root of x minus 5. Okay, now we square both sides. And since we're squaring both sides, again, we're going to have to check our answers. The left side is just 7x plus 1. Now, the right side is a little more complicated. So I'm going to actually do it by hand, just to make sure you understand the algebra involved here. So 6 times 6 is 36. 6 times that root is just plus 6 times that root. And then this root times 6, again, is another 6 times the root. And then the last multiplication is the square root of x minus 5 times itself, which means you're really just squaring it. So what happens is you get just what's underneath the root. Okay, so that's root x minus 5 times itself, which means square it, so it kills off the root, and you just get the x minus 5. Okay, here what we can do, we can combine these two together. So we have 12 of those roots. 36 take away 5 is 31, and then plus x. Okay, so this becomes, and it doesn't matter what order you write this in, but I'm going to put it, I don't know, I'll just do this. Like that. Okay, now what we're going to do is realize that we have another radical equation now where our radical is this one, so we need to isolate it. And because the 12 is attached to it with multiplication, I'm going to isolate everything there in blue, which means I'm going to subtract x on both sides. I'm going to subtract 31, which gives me negative 30. And that should leave me 12 times the root of x minus 5. All right, now, at this point, I could try and get rid of that 12, but it's going to make things more complicated if I do that. So I'm actually going to square at this point. I already knew I had to check my answers from earlier, but now I really have to check my answers. So on the left, I have to square this 6x minus 30. So I have to multiply it times itself. That's going to suck. And then because this is multiplication, I can square each of these. So I square the 12, I get 144. And when I square that square root, I get x minus 5, but it's important to remember that that 144 is going to multiply times that. So I have to put that x minus 5 in parentheses. Let's see, on the left side, I get 36x squared. Let's see, this times this, that's negative 180x. The middle, I get negative 180x. These numbers are getting big. And then minus, let's see, 900. Yeah, so that's the, oh, minus, it's plus, sorry. Negative 30 times negative 30. Okay, and then on the right side, let me distribute. So I get 144x, and then just to make sure I'm getting this right, minus 720. Okay, now let's get our like terms. So if we put those two together, we get 36x squared minus 360x plus 900 equals 144x minus 720. All right, we have a quadratic equation. Let's move everything to one side. So I'm going to subtract 144x. I'm going to add 720. So I should get 0 on the right side. And then 36x squared minus, what is that? 4504x. And then plus 1620. All right, I think, let me just double check this. I think that 36 goes into all of those. So we should be able to factor it out. Yeah. So if we factor out a 36 right now, it'll make our life a lot easier. Pull out 36 there, pull it out from the 504, we get minus 14x, and then pull it out of the 1620, we should get plus 45. And now we can factor this, hopefully, into two things. It looks like minus 9 and minus 5 should work. So now we set each of these equal to 0. And a lot of times students wonder, like, what do you do with this? Well, we're asking ourselves, when is 36 equal to 0, right? And it's never equal to 0. So we can ignore it. Another way you can look at this is just divide both sides of the equation by 36. And it goes away, and the right side's still 0. So at the end of the day, you're still, all you're looking at are these factors. So you can completely ignore this 36. It's not going to contribute any part of the answer. So we get two answers, 9 and 5. And now we have to check them, right? So we got to check them. Let me copy this and put it down here so I can see it. So let's check 9 first. If I do 9, I get square root of 7 times 9 plus 1 minus the square root of 9 minus 5. Does that equal 6? Let's see. 7 times 9, that's 63, plus 1 is 64. The square root of 64 is 8. Minus, let's see, 9 minus 5 is 4. So square root of 4 is 2. 8 minus 2 is 6. So yes, it works. So I do know that's an answer. And then I try the other one. Try and put 5 in here. So 7 times 5 plus 1 minus the square root of 5, sorry, 5 minus 5, does that equal 6? Okay, well, 5 minus 5 is 0, so that's gone. This is 35 plus 1. 35 plus 1 is 36, and then you take the square root, so you get 6 here. And 6 does equal 6. So we are good, they both work. So let's go put this answer in. Two answers, 9 and 5. So it says, do you use a comma to separate the answers? So 9 and 5. I guess it doesn't matter what order I put them in. All right. This is a good one. All right. So for this one, we want to solve this equation. Okay. So this is kind of a tricky. We did not do one of these in class. Interesting. Okay, well, we can still do it. So what I want you to notice here is that we only have two terms equal 0. So if I can factor out a GCF, then I should be able to solve this. So when looking at these powers, we have x to the 3 halves minus 37x to the 1/2 equals 0. Both of those terms have x to at least the 1/2 power. So I'm going to pull an x to the 1/2 out and then see what I would be left with. So let's start with the last one first. So when I multiply this through, I need two terms to be able to come back to this. So I know I'm going to need a minus 37 here, because this times this should give me this. Question is, what do I multiply x by, x to the 1/2 by, to get x to the 3/2? Well, it's got to be x itself, x to the first power. And the reason is because when you multiply x to the 1/2 times x to the 1, that's really x to the 1/2 plus 1. That's properties of exponents. If you have the same base and different powers, you add the powers when you multiply them. And 1/2 plus 1 is the same as 1/2 plus 2 over 2. And that's going to be x to the 3/2. So we need just an x here. And now we have multiplication. So we set each of these equal to 0. So x to the 1/2 equals 0. And then the other equation is x minus 37 equals 0. This gives you x is 37. Oop. And then this one, this is the same as saying the square root of x equals 0. Well, the only number you can take the square root of and get 0 is 0 itself. So x is 0 is the solution here. Now, we never squared both sides of the equation, so these answers should work. Let's go check them. 0, 37. There we go. All right, now in this problem, we have something a little different because we actually have 3 terms on the left-hand side, 1, 2, 3. So we can't do what we just did because there's no GCF. But if we squint our eyes, this is that problem where we squint our eyes and we realize that that x to the 4th is x squared squared. And then minus, again, that x squared, then minus 1 equals 0. So if we make a substitution and replace that x squared with, let's say, u, then the problem would become 6u squared minus u minus 1 equals 0. And then that should factor, let's see here, 3u, 2u minus 1 plus 1. Let's check that real quick. This is going to be 6u squared plus 3, minus 3u plus 2u, that gives us minus u, and then minus 1. So that should work. I set each of those equal to 0. Okay, on this one, I move the 1 over, so I subtract it. I divide by 3, I get negative 1/3. And then on this one, I move the 1 over, add 1 to both sides, and divide by 2, so I get 1/2. And now, very important, we have to go back to our substitution, replace u with x squared. So this one becomes x squared is negative 1/3. And this one becomes x squared is 1/2. Now on the left one, there's no solution here because there's no number that you can square and get a negative value to come out. No real number. So we know that this won't work. This one, we have to take square root on both sides, which means we have to do plus or minus because we initiated the square root. And so that gives us x equals plus or minus the square root of 1/2. Now, I don't know if it's going to take this answer because they may want you to do, let's see, square root of 1 over square root of 2, split it. And then the square root of 1 is 1 over root 2. And then they may want you to rationalize, which I already told you is not necessary, but this would become root 2 over 2. Let's see if it takes this answer here. Okay, so it wants us to separate our answers. We have 2 answers. So one of our answers is a fraction. It's 1 over the square root of 2, and then comma. The other answer is negative fraction 1 over square root of 2. Let's see if it takes that. Come on. Okay, so maybe they want you to rationalize. So you know what? I'm just going to get it wrong again because I want it to tell me what the answer was. Yeah, see, they wanted to rationalize it. See, I wouldn't ask for this, okay? If you were taking a test, I would accept these answers. So we'll move on. Next, how do we go to next question? Yeah, okay, so this one is a similar setup. Okay, because again, we have three terms, and if we squint our eyes appropriately, we can kind of see that this looks like a quadratic. So we need to realize that x to the sixth is x cubed squared plus 56x cubed, and then minus 512 equals 0. So if we make a substitution that u is x cubed, then this becomes u squared plus 56u minus 512 equals 0. All right. Okay, this should factor, but I've got this one's not so easy. I need to figure out two numbers that multiply to be negative 512 and add up to be 56. 512 add up to be 56. I'm using my calculator to kind of help me here. 8 and 64. Yeah, 8 and 64. Kind of got lucky there. So I'm going to have 64 here and negative 8. Those two multiply to be 512 and a negative 512 and add up to be 56. So this will become u, not x, careful, u plus 64, u minus 8 equals 0. And you get two answers. U is negative 64 and u is 8. And now remember what u was. U was x cubed. So x cubed has to be negative 64 and x cubed has to be 8. And now we're going to take the cube root on both sides in order to kill off the cube. You have to do it on both sides. And you do not have to do plus or minus because it's an odd root. So anytime you have an odd root, you don't have to do plus or minus. So the cube root of negative 64 is negative 4. And that's because negative 4 times negative 4 times negative 4 should give you 64. And then, let me see here. The cube root of 8 should be 2 because 2 times 2 times 2 is 8. So we should have two solutions here. We never squared both sides. Yeah, we should be good. Negative 4 and 2. Negative 4. Oh. Negative 4, comma 2. And move on. How many more problems do I have? I'm only on problem 8. So for this one, again, we have something that kind of looks quadratic. Actually, yeah, it kind of does. We don't have 0 on the right-hand side. So the first thing I'd want to do is move that 4 over. S plus 9 squared minus 15 times s plus 9 minus 4 equals 0. And now I'm going to make a substitution that u is the s plus 9. And if I do that, this becomes 4 u squared minus 15 times u minus 4 equals 0. So all I did was replace the yellow with u and then rewrote it as a quadratic. Now this should factor. Let's see if I can get this factoring going here. So it looks like I'm going to have, let's see, let's try this, 4u and u, and then minus 4 and then plus 1. Let's try that. So 4u squared minus 16u plus 1u, that's negative 15u, and then minus 4. So this works. I'm not showing this work really because, you know, we're kind of coming into this class hoping that you know how to factor. Again, if you are having trouble with this step, I gave you a processing class, but that's something that takes time to get good at. So hopefully you can get caught up and get up to speed on that. All right, here we go. 4u plus 1 equals 0. Set each of these factors to 0. And then this one will be u is negative 1/4. And then this one will be u is 4. And now we replace u with s plus 9. So s plus 9 must be negative 1/4. And then the other one is s plus 9 has to be 4. Okay, the one on the right's easier, so I'll do that one first. I subtract 9 on both sides and get -5. This one, I have to subtract 9 on both sides and then get a common denominator so I can put these together. So rewrite 9 minus 9 is minus 36 over 4. Now that those have the same denominator, I can put the numerators together, get minus 37 over 4. So it looks like I've got two answers here. Negative 37 over 4, negative 5. Negative 37 over 4, comma, negative 5. There we go. All right. Okay, so this problem can be done two different ways. Okay, this one can be done treating it as a radical equation, or if you do kind of squint your eyes, you can see that you can first move everything to one side to make it look kind of like a quadratic trinomial. Kind of, it's not a quadratic yet, but we're going to do something. We're going to realize that that x right there, we did this in class, is actually the square root of x squared. You have to realize that. Then you have plus the square root of x again, and then minus 42 equals 0. And so you can see these are the same. That will be our substitution. And then at this point, we can rewrite this as u squared plus just u minus 42 equals 0. And that becomes u, let's see here, 42 is 7 times 6, so we get positive 7, negative 6 equals 0. We get two answers from that, negative 7 and 6. Now we need to replace u with the square root of x. So the square root of x equals negative 7, and the square root of x equals 6. Now I'd have to square both sides in order to do these. And now that means I'm gonna have to check my answers. Now on the first one here, I'm gonna actually, before I square it, I just want you to think about this. Is it possible to take the square root of a number and get a negative answer? It's not, we can't, all right? So this we know is not gonna, this solution is not gonna work. If we did this step, we would have got x is 49. And then when we checked it, it wouldn't have worked. I'll leave that to you to verify. The other one gives us x is equal to 36. And I will check that by plugging it into this. So 36 plus the square root of 36 minus 42 needs to be equal to 0. So this is 36 plus 6 minus 42 equals 0, which is 42 minus 42 equals 0, which is right. So the only answer we should get is 36 here. Next one, another quadratic type. All right. You know, part of this is just the recognition, right? So I'm just telling you right now it's quadratic type, but or quadratic form. But you know, if you're not familiar with these, it's not maybe not so easy to see it. So here's the way I'm going to do this. This x to the 2/3 out front, I want you to look at that as being x to the 1/3, but then squared. And we have to remember that when you have something to a power, you're multiplying those powers together. So if I take 2 and multiply times 1/3, I get 2/3. So that's why I can rewrite x to the 2/3 as x to the 1/3 squared. Now I did 1/3 because this middle term has a 1/3 on the x. So now I can rewrite this 5, and then this becomes that x to the 1/3, but squared, that's what this is. Then minus 44, and then that x to the 1/3 again, and then minus 9 equals 0. Now I put these in parentheses just so you can see them better. I mean, that's what our u substitution is going to be. U is equal to x to the 1/3. This one you have to put in parentheses because you're squaring it. This one does not have to be in parentheses, but I do it again just to illustrate the part that's going to be replaced with u. So 5u squared minus 144u minus 9 equals 0. And that looks terrible. 45, how's that going to factor? This one's going to be a little, you know what? This would be a good time for me to maybe do it the other way. So I multiply here times here, I get negative 45, and then negative 144. Oh, okay. What numbers multiply to be, that add to be that? Oh, you know what? Oh, I see the problem. Okay. I see the problem. Oops, I copied it down wrong. This was a 44 and I put 144. I was getting a little panicky there because I was like, that's not going to work. Okay, this needs to be negative 44. So this means that we can use negative 45 and 1. That'll work. So watch how I do this. This is very important because this number out here is not a 1. We have to be careful how we do this. I'm going to do this by grouping. I rewrite this equation. I leave the first term and the last term alone, and then I use this. I take this and I split it up using the two numbers that I just found. So this becomes minus 45u and then plus 1u. Okay. Now what we do is grouping. So we do, since we have 4 terms now, we do grouping. So I have the first term, first 2 terms, I pull out a 5u. I'm left with u minus 9. And then over here, I already have a u minus 9, so I have to factor something out. So I'll factor out of 1, leaves me with u minus 9 equals 0. And see, they both have u minus 9. So I can rewrite this as u minus 9 times 5u, that's this thing, plus this right here, equals 0. And now I finally have this factored. So this will become, set these each equal to 0. I'm not going to show the work. You get u is 9. And you get u is equal to negative 1/5. Now, what was u? U was x to the 1/3. So this is really x to the 1/3 equals 9. And x to the 1/3 equals negative 1/5. And now to get x, I will cube both sides. Cubing, so I don't need to check my answers. Okay, 9 times 9 times 9, right? We have to do that, and then we have to do negative 1/5 times negative 1/5 times negative 1/5. So this is going to be x is 729. This one, x is equal to, okay, well, a negative times a negative times a negative should mean we have a negative answer. If we cube the top and bottom separately, 1 cubed is 1, and 5 cubed is 125. So those should be my two answers, 729 and negative 1/125. 729 and negative 1/125. Good. All right, I'm having a little panic that I'm maybe not recording. Am I recording? Okay, so for this one, we want to solve this. Noticing I have 2 terms and they both have x in them. So it's not a trinomial, it's just 2 terms, binomial. So I'm going to factor out an x, leaves me with x squared minus 25 equals 0. And then I recognize the x squared minus 25 as a difference of squares. And now I can set each of these equal to 0, and I get 3 answers, 0, negative 5, and 5. And that's it. I didn't do any squaring on both sides or anything, so I should have 3 answers here. That one's actually easier than the other ones. Okay, for this one, we're going to recognize that we have 4 terms. And because we have 4 terms, I'm going to be thinking grouping here. So I will take the first 2 terms, put a slash. I'm going to factor out, let's see, I pull an x squared out of both of those. I'll be left with x minus 4. And then over here, I need to be left with an x minus 4. Right now I have a negative x plus 4. So I'm going to factor a negative 1 out of both of those. That'll give me an x minus 4 and equals 0. Since the x minus 4's match, I write x minus 4 in parentheses, and then another parentheses, I write x squared, that's this. And then this one right here, minus 1 equals 0. And again, I'll recognize x squared minus 1 is a difference of squares. So it's x plus 1 times x minus 1. And that should give you 4 answers, 3 answers, 4, negative 1, and positive 1, setting each of those equal to 0. So 4, comma 1, comma negative 1. It doesn't care what what order you put the answers in. All right, next one. All right, again, this is going to be a grouping problem. Almost out of time. I've got other things I have to do here. I need to move everything to one side first because I have 2 terms on the left and 2 terms on the right. So when I bring stuff on the right over to the left, they become subtracted. And then I do my grouping. So slash it, I can pull a 4x out. I'll be left with x squared. Let's see, if I pull a 4 out of this, I got plus 5 like that. And so I need this to be an x squared plus 5 also. So I need to pull a negative 5 out of both of those. I'll be left with x squared plus 5 equals 0. So GCF on this of negative 5. And now these 2 things match. So this becomes x squared plus 5. And then the 2 things that were in front, 4x minus 5 equals 0. Okay, this one's a little bit tricky. This right here, you set equal to 0. And then the other one you set equal to 0, the other factor. This factor, I assume you could do, just move the 5 over, divide by 4. This one, you'll get x squared equals negative 5. And this will have no solution because there's no way you can square a number and get a negative, not a real number. So no solution here. So we should only have one answer, 5/4. Oh, oops, I didn't click in there. 5 divided by 4. All right, how are we doing here? Last one? Is this the last one? No. Yeah, I think this is the last one. Find the real solutions, if any, of this equation. What the heck? Okay, find the real solutions of the following equation. If k is equal to this, and k squared minus 4k equals 12, find x. Okay, so here's what I'm going to do. First thing I'm going to do is I'm going to try and solve this equation for k. So I have k squared minus k. I'm going to bring the 12 over and make it like this. Okay, so it's quadratic. Now I'm going to factor it. And I should get here minus 4 plus 3. And that gives me 2 solutions. K must be 4 or K must be negative 3. So setting both of those equal to 0. All right, so that's what K has to be. But what is K? K is x plus 2 over x minus 2. So I have x plus 2 over x minus 2 must be 4. And this one is saying x plus 2 over x minus 2 must be negative 3. So now we get to solve these. Now, we hadn't done any of these in class, but what I'm going to do is, this is a rational equation. So I'm going to multiply both sides by the denominator, x minus 2, to clear it on the left. That leaves me with x plus 2 equals, and I'll distribute the 4 through, so 4x minus 8. That's a nice little linear equation, so I can just like subtract x here, I can add 8, and get 10 equals 3x. Divide by 3, I get 10/3. And then on this one, same thing, multiply by x minus 2 on the left, by x minus 2 on the right. Cancels, I get x plus 2 equals distribute, so negative 3x plus 6. And then this time I'm going to add 3x on both sides and subtract 2. So that gets all my x's on the left, 4x, and on the right I get 4, 6 minus 2, and that gives me 1. So 10/3 and 1 should be our 2 solutions. 1 and 10/3. Uh-oh. What the heck happened? Did I mess something up here? Okay, let me just double check this. Okay, that's a minus there, brought that 12, 4, 4, 3, negative 3. Okay, negative 3, x plus 6, x minus 2. Okay, I think that looks okay. Subtract 2, 4. Add 3. That looks okay. Hold on, let me see this side. 4x minus 8. Add 8. What the heck? Let's see. Let's see what it says. Let's just put the answer in again. Oh, geez. Are you kidding me? Okay, I didn't read the instructions. Sorry. Instructions say to round to 2 decimal places as needed. So I don't know, for some reason on this problem, they actually did not want the fraction. They wanted the decimal. It's ridiculous. All right, it is what it is. Don't get frustrated with the system, with the computer system. If you're doing the math right, all's good. Okay, hope that helps.